Hi everyone, welcome to new video of new series which is stable diffusion. So in this series I am hoping to explain you everything related to stable diffusion, and after the end of this series you should be pretty confident generating your own images. So in the part 0, which is this part, we are going to see how stable diffusion works, how the stable diffusion model work behind the scenes, what are VAE, how the training part goes on, what are the noise images, what is latent space, like everything related to stable diffusion. And in the part 1 we will going to install most of the two popular UIs, which is Comfy UI and Automatic 1111. I'm going to explain both of the UIs, and then later on you should have heard of text to image, image to image, image in painting, AI upscaling, image upscaling, and then very interesting control net. That also, this is going to be a very exciting journey. And then later on, how to do fine tuning as well. In case if these videos generate enough income, I will buy some cloud GPU and then going to explain it to you how to fine tune the stable diffusion models on your own images, 5 to 10 images. And we are going to see how to fine tune using Dream Booth as well as textual inversion. So this is going to be a big journey. I hope you are interested in this. If you are, consider subscribing because the videos are on the way already. Let's start the part 0, which is how the stable diffusion model are trained and how the inference part goes on. So for training, let's say you have an image on which you want to train your stable diffusion model. So what happens, a noise is generated of same size as the image, and this noise is added to the original image. So our resultant image is created, which is again with the noise, since the noise is added. So our model, which is UNet model, is deployed to predict the noise inside this image. So the task of the UNet model is to predict the noise in the resultant image, which again has to be equal to this particular image. So once the noise is predicted, again the noise is generated in the second step. Again the addition operation happens, again the resultant image is created, again the UNet model is deployed in order to predict the noise inside this particular image. Again the noise has to be equal to this particular noise. I hope you are getting the point. So the UNet model is trained basically in order to predict the noise in the image. So after a few steps, it should be clear to you that you get a pretty noisy image, and the task of the UNet model would be to take this particular image and predict the noise inside the image. So now I hope you understand like how the images would have been generated. So essentially what happens, a completely random noise is generated and it is given to the UNet model which we have just trained, and UNet model is going to give us the noise in the image. So that noise is taken and subtracted from this particular image. So a new image is created with less noise. Again the UNet model is taken, the UNet model predicts the noise, and again the noise is reduced. So this particular thing I'm talking of inferencing. This is like pretty much overview how the things work at the top level domain. But this is not exactly how the things work. The things are pretty much different over here. So over here you see, like suppose you are training your model on 512 by 512 images, which is again RGB. So this particular much calculations has to occur inside the GPU memory, which is going to be a big number. So there has to be some way in order to compress down the image, train the model, which is our UNet model or noise predictor, and then again decode the lower space image in order into our original, which is 512 by 512 image. So how does that thing occur? So for understanding that, model is taken, which is VAE, or also called as Variational Autoencoders. So understand Variational Autoencoder like in this way. Suppose you have a big image of 512 by 512, something like this. So VAE, what it do? It takes this particular original image and compress it down to a smaller representational vector, which is also known as latent space vector. Now if you want to decode this image, this latent space, into the original data, again VAE is used in order to decode this image into the original data. So this happens in two parts. The first part is known as encoder and the second part is known as, of course, decoder. So you should have heard of VAE encoder or VAE decoder. You're going to see more about them in the further videos. So this is essentially what happens. So instead of adding the noise into our original image, which is 512 by 512, the image is compressed down to a latent space vector. For training, the noise is generated again of same size, this is added, then the unit model is used in order to predict the noise in the image, and this thing goes on for training part. For inferencing part, the unit model is used to predict the noise, and the noise is reduced from the input image. I hope you are getting the point. So now you might be asking like where the text prompt fit in. Like we have never mentioned about text prompt. Like suppose if you have heard of stable diffusion models, we provide it a prompt like a man walking. So the image, the prompt is given and the image is generated, right? So where does the prompt occur in the training part? So let's just talk about that now. So up till over here, you understand that you have a completely random noise image. You give to a, let's just represent noise predictor, and you give the image to noise predictor. The noise predictor predicts the noise and you subtract the noise from the original image, and this cycle goes on, let's say up to 20 steps. So this whole process is unconditional image generation. I guess you might have heard of it. So for text embedding, so what happens, suppose a prompt is given a man. So what happens, this text string has to be converted into tokens. So let's say tokens are like 45, A is converted to 45, man is converted to 105, walking is converted to let's say 400, and that's it. So once the tokens are generated, let's just represent them by a column vector like this. It has to be converted into the embeddings again of 748. So the resulting would be 3 times 748 vector. Now if you don't understand, if you don't have any understanding of what embeddings are, I have explained it in the previous video part 0. I will link it down in description as well as in that I button. What embedding model do, it takes in the word, convert it into the token, and it generates a vector representing particular word. Now good thing about embedding is that similar words have similar values of this 748 vector. So up till now over here you understand like you have the prompt and it is now converted into a, let's say, n times 748 matrix, and where n is the number of tokens. Now this particular thing is given to the transformer model, and the transformer model transforms this particular matrix such that it can be fed to our noise predictor. So the noise predictor predicts the noise, and we have a random noise already over here, and the noise is subtracted from the random noise. Again, this process just goes on and on. So you can understand like this prompt is now converted into a random noise, but which is not much random, but it is something related to the prompt. So the prompt is fed to the noise predictor. The noise predictor predict the noise, subtract the noise from the random noise image. Again, the new image is fed to noise predictor. Again, the noise is predicted, reduced from the noise, and just cycle just goes on. I know a lot of things I have just explained. You can try rewatching. If you still have any doubt, you can ask down in comment section. I will also leave a pretty beautifully written blog in down description. Consider checking that out. A lot of things will going to get clear. Up till now, what you understand, we have the prompt. The prompt is fed to embedding model. A matrix is generated, matrix of embedding. That matrix is fed to the transformer model. The transformer model transforms this into a random noise, which can be fed to our unit model, which is again noise predictor model. Let's just call it NP. That noise predictor model predict the noise, and that noise is subtracted from our original input image, and this cycle goes on, and this is called as steps. And if you have any time used any UI, you should have heard of this step value. Sometimes it's set to 20, sometimes it's set to 30, sometimes it's set to 15. Depending on the number you set on, you get better or worse image. So I hope all your doubts regarding the working of stable diffusion is cleared now. Now you know what tokens are and everything related to what noise predictor is, what latent space is. I guess all your doubts regarding that should be cleared. So if you have any doubts regarding that, you can consider asking them in down description, or you can mail me. So that's it for this video, and in the next video we will install both the UIs, Comfy UI and automatic 1111. This is going to be an exciting the theoretical part is over. Now we are going to generate some images from the next video. So till then, goodbye. Read the blog which I will going to leave in down description. Consider checking out embeddings more clearly. I will see you in the next video. Till then, goodbye.